Uh, Next up, we have Manish Karar, and he's presenting Cloudy with a Chance of Breach, forecasting cybersecurity incidents. Thanks.
Thanks very much. So this is going to be a little bit of a meta talk. It's not going to be about moving routes around. It's not going to be about moving packets around or not moving, blocking them. It's going to be a little bit about some thoughtful strategic thinking. It's going to be a little bit about policy. It's going to be a little bit about measurements. And it's going to be a lot about data. So let's get started. So I'll be talking about forecasting cybersecurity incidents. I'm Manish Karir. I'm the CDO at Quadmetrics. But the work I'm presenting here really was led by some fine folks at both the University of Michigan and Illinois: Yang, Armin, Jing, Parnas, Michael, and Mingyan. So what's the background? What is this? What was the problem, and where did the problem come from? The underlying premise of this work was that sort of reputation matters. Your reputation on the internet does matter, and security posture of your organization or of somebody else's is or should be an important part of a business relationship. Asked this to just T-Mobile and Experian last week when they reported the data breach. Perhaps T-Mobile could have made a different choice with a vendor if they had known the risk probability of Experian. They had a choice of vendors, and they chose one, and we have the data to show that they could have made a different choice which might have had a better result for them. Finally, the issue with doing this, though, is that security posture is a sum total of many, many factors. It includes people, training, it includes technology you deploy, how well you deploy it, as well as processes. What mechanisms do you have in place to manage and monitor and fix things? And the problem is measuring these things is really hard. And you need metrics to be able to do it, so you can be structured and thoughtful about how you're doing it, so it's not apples to oranges comparisons, it's apples to apples, repetitive over time, so that you have consistency. So finally, you need to be able to do this at scale, because you need this information not just about yourself, you need it about all organizations that you might potentially deal with. And finally, who has these kinds of problems? Well, for example, the Department of Homeland Security, which was the initial funding behind this research effort, has this problem of being able to assess critical infrastructure. They can't go on site, they can't deploy packet taps everywhere, they have to have some reports, some independent way of generating risk aggregation information. Companies have need for this as well, where they're talking about measuring third-party risk, managing their vendor relationships, and they have a need for this information to understand their own security posture, not just their current status, but how are they making changes that are making this better or worse over time. And finally, the important one, we see the cybersecurity insurance marketplace stepping into this area as well. They're starting to write policies, and they need to be able to base those policies on actuarial information and sound statistics. And we all know the 2014 breaches that were top headlines, including Target, Home Depot, JP Morgan, on and on and on. And in some of the work that I'm going to talk about, those were actually case studies. So the one-slide summary of what this talk is really about is this. We use internet-scale data measurements and machine learning to do predictive cybersecurity risk analysis of organizations. And the information is useful for underwriters to set premiums for cyber insurance. There are several other things you can do there as well. Several innovations you can think about when it comes to doing cyber security insurance, because it really is a little bit of a different beast than normal insurance policies that they're used to. And finally, network managers or administrators can use this information to measure the security posture of their own enterprise, and as well as the risk of their partners. So let's get into the nitty-gritty detail of how we do this. So largely, it's all about the data. It starts and ends with the data. We do large-scale internet measurements. What do we measure? Everything. We're talking about measuring active risks. We're talking about measuring latent risks, as well as mismanagement indicators. We do modeling and feature extraction based on the data that we do collect. We have to do aggregation of all this data up to an organization level. That is just by itself a challenging task. we have to develop features. What are we going to model? What are the characteristics that are potentially interesting that should be fed into the models? And finally, cleaning the data for the labels is an extremely challenging task. Remember, we have to collect historical information as well, and most of that is reported by organization, not IP addresses. So you sort of have to do this manual process of matching breach information into aggregation. But more about that in a little bit. Finally, once you've aggregated data, you've cleaned this data, you can actually apply standard machine learning techniques. We use a random forest machine learning algorithm, and at the end of that, you end up with prediction scores based on your models, and then you go through an exercise of doing a validation. What is your test set? What is your training set? And so on and so forth. So, mismanagement symptoms. What are some examples of things that you can look for in terms of data sets about the internet? You can look at, for example, open recursive resolvers. Thank you, Jarrett at NTT, for the fine data set. That's one of the data sets that we used. Another example might be you can conduct tests on DNS source port randomization. Who's implementing it, who's not. You can look at BGP misconfigurations, the frequency at which these events are occurring from an organization, whether it's typos, intentional, anything, slip-ups. Or you can just look at something at the application layer, talk about untrusted HTTPS certificates. What is the ratio of expired certificates, locally signed certificates versus legitimate external certificates? And even OpenSMTP relays that may exist at an organization. All of those may or may not be directly related to a breach, but the key idea is they're indicative of patterns in an organization. And remember, when we're talking about modeling at such large scales, you're looking for subtle hints that when all aggregated, put together, will give you a comprehensive view of what's going on at an organization. What are examples of malicious activities data? This is relatively simpler to understand. So malicious activities are usually of the kind of spamming, scanning, hosting malware, phishing sites, and these can be aggregated from a wide variety of sources. Things like SpamHouse, SpamCop, a lot of phishing lists are available out there, as well as darknet scanning sensors can give you a hint of botnet activity. And all of this information is stuff we gather and aggregate and model. And finally, this is the hard part in machine learning, getting ground truth data to label your models. We use 3 different sources to build our collections of incidents. The most commonly cited database is, of course, the Verizon data breach report dataset. This has about 4,000 to 5,000 reported incidents, publicly reported incidents that have been gathered together. There are a couple of other reports like the Hackmageddon or the Web Hacking Incidents Database. These are maintained on a voluntary basis by individuals. And so we aggregate all of these 3 different sources together. They each have their different biases in terms of kinds of incidents that are reported. So altogether, it gives us a very good distribution of the kinds of incidents that are being collected in this data set. Now, once we've collected and cleaned all of this data, comes the hard part of actually developing features that we're going to build our models on. We develop about 250 different features, and we're aggregating a lot of this information up. Some examples of features might be simple features like mismanagement symptom ratios, number of invalid certs to valid certs ratios, open relays to well-configured mail servers at an organization. Other things might be simple time series of RBL activity at an aggregated scale, or fractions of an address block that are part of an RBL, all giving you subtle hints along different axes of the security posture of an organization. And finally, some of the more interesting features that we also look at are not just first-order statistics, not just the raw counts or ratios, but also how these are changing over time. So we look at 2 to 3 month trending of this data, and we can develop derived features like frequency or duration of different malicious activities. Those are also fed into our models. Finally, and this actually turns out to be the easier part because there are lots of libraries that you can, standard machine learning techniques that you can apply once you've cleaned the data. We use a simple random forest machine learning classifier. It uses a sampling approach to build a forest of decision trees and does an averaging across all of those, so you get some robustness and resilience against imperfections in the data. And very interestingly, we use a 50-50 training and testing test split. What does that mean? So what we do is we take the sum total of activities, breaches that are reported in the 2013-2014 timeframe. We divide that into two parts. The first part is a data set that we use for actually training our models. So we use that to feed into the algorithms, they generate a model, and finally the model is trained. We use the other half of our training set as incidents we pretend we know nothing about and use that to evaluate the accuracy of our model. So this is the test, we pretend this is going to be a blind test. Let's pretend we know nothing about these. How well could we have done in predicting all of these incidents that show up in the second half? And that's the second half of the incident. And I'll talk about the results in the second half of the talk. Finally, the testing is used to evaluate and demonstrate the accuracy of our models. And of course, being the scientific paper that this was, there's a lot of time and effort spent on training, on multiple windows, multiple data combinations, multiple parameters for the machine learning algorithms. I'll skip over the details of those because those are in the paper. So the results. Here's the overall false positive, true positive from the evaluation exercises we run on our data breach prediction. Overall, if you look at the black line with the triangles on it, that is when you're looking at the prediction of events across all of our data breach sources. Remember the 50% set that I mentioned that we were going to use for our testing? What we're looking at on the y-axis is the true positive percentage, and on the x-axis, the false positive. So if you look at where those two horizontal dashed lines cross, you will see that's about the 90% mark for true positive and the 10% mark for false positive. What this means is, for the 50% of our data set that we pretended we knew nothing about, our models were able to predict with a 90% accuracy that those incidents were from organizations that had a high risk. In other words, their data indicated that those organizations were doing things that were more likely to lead to breaches than not. In terms of the different features that we test for, there was a clear differentiation between the kinds of features that were more important, relatively more important than others. Remember, we were measuring for a wide variety of characteristics. But as it turned out, our hunch that mismanagement features would be the most predictive was actually correct. What you're looking at in this chart is the contribution to the overall importance of the different features. If you look at the top row there, the mismanagement features were contributing about 30% to the overall score for different organizations. And the other features are listed there as well. And this sort of was very interesting because it confirmed our intuitive understanding that the human element is the most important factor in cybersecurity. However, and this is the twist in it, can you just use the mismanagement features to train your models? Why do you even need the malicious activity data set? So we did the exercise where we split out our data and just used the mismanagement features to build our models and test. And as it turns out, if you look at the blue line there on this chart, mismanagement features by themselves have an extremely low true positive, false positive ratio. What works well is the combination, or the red line, where you look once again at the 90% accuracy mark. The red line on the chart is once again displaying a true positive of about 90% and a false positive of 10%. So as it turns out, the most interesting result of the study is that it's not just one or two things that you need to measure about an organization in order to develop a cybersecurity prediction model. You need to look at all of them. And the intuition behind this is actually very interesting. So remember, cybersecurity at an organization is not just a matter of securing the routing path. It's not a matter of securing just the DNS servers. It spans the whole organization. So you're looking at securing everything from the web applications, to the DNS servers, to the workstations, to the servers, to the switches in the closet that people forgot. Oh, and also there's the Polycom units in the conference room that need to be secured as well. And that is sort of the intuitive understanding behind why you need to be able to collect as diverse a set of data as you can about an organization, to be able to capture all of these different elements across many different sub-organizations within an organization. And finally, this was a chart that summarizes or attempted to place on our prediction models where some of the more high-profile incidents during the 2013-2014 time span fell in terms of our prediction ratios. What you're looking at is the CDF chart of, which is on the y-axis, and on the x-axis you're looking at our predictor output scores. Remember, the numbers are really percentages, so 0.8 actually means 80%. And we've placed, for example, Sony Pictures with a risk probability of 90% chance of breach. They actually did have an incident. You're looking at the vendor for, the Target is listed there as well as an 84%, and the vendor for JP Morgan Chase is listed on there as well. Online Tech, which is a 92% probability of breach. So you're looking at fairly accurate predictions in terms of incidents that did occur, the organizations that were high risk in that time frame. And since the paper's been published, so remember our models were trained in about 2013, 2014, and the flow of data breaches has not stopped. So this is sort of an update on where we are in terms of our prediction accuracy. There's been Anthem Healthcare. We had them at about a 90% probability of breach. They reported a breach in March of 2015. Same with Penn State, Rutgers, Office of Personnel Management, and even Experian last week. So the accuracy of the models has actually held up remarkably well over time. So in conclusion, it is possible to statistically predict cybersecurity incidents on the basis of historical incidents, which is really what we're doing. And remember, what we're using is pre-incident data about these organizations. They have not currently reported a breach. We're looking at characteristics that are pre-incident, and we're using those to build models and compare those models to historical models of organizations that did report a breach. And the difference between detection and prediction is key. Detection relies heavily on signatures, and you have to have a signature or a 0-day already in play for you to have a signature. Prediction is about looking at patterns that may even not be the reason for a data breach. It's the equivalent of asking people how often do you work out or how often do you go to the gym, and then trying to develop their life insurance policy for them. Security posture at an organization is a many-dimensional problem, and it requires data from many parts of that organization. And finally, protecting against data breaches requires fighting a battle on many fronts. You need to have a policy that applies to the whole organization, and that spans across all different sub-organizations at a company. Lots of time for questions. Sandy?
Sandy Murphy, Parsons. So your graph that said, here's all the measurements against the people who have had break-ins. So I could invent a measure that just said everybody has a 90% chance of being broken into.
Absolutely.
And then everybody who had an incident, I could say, look, see, it's a wonderful predictor. Have you looked at
Yes.
benign examples, people who are really strong and say, oh, look, our measure shows they're really strong?
Yes. So both as a population and for specifics. The blue line on this chart talks about the distribution for the general population, which did not have security breaches, and you can clearly tell that the distribution of scores is different for those. But I think what you're asking specifically for is there a distribution? Is there a mean in terms of what does an average organization on the internet look like? And for the data reported in the paper, there was a very nice two-hop bell curve, which focused on a 50% probability. So, a score of 0.5 was actually where most of the organizations existed, and only about 10% of the organizations had scores greater than 85%. So only 10% of the organizations on the internet had scores greater than 85%.
Okay. And another question is, I wondered in your case of mismanagement if you'd considered things like the release level for the various pieces of software that people are using and their ability to accept out-of-date crypto algorithms and how fast they're doing patches and stuff.
Yes, so that's one of our ongoing efforts right now. We're looking at many different aspects of aggregating mismanagement information, both version levels, patch levels. So we are continuing to expand that, but not for the results in that paper.
Okay, thank you.
Thank you. Go ahead.
Matt Petak, Yahoo. So here you have a nice chart that shows data that reinforces your hypothesis. It's the good chart, the stuff that says, look, my model was right. Do you have cases of companies where breaches were reported, but your model predicted them as having a low probability of breach, would be the first question. And
Yep.
if you did have cases of company breaches where your model did not predict that they were likely to have a breach, does that indicate that there are additional dimensions of data that we perhaps should be factoring in that aren't as obvious, that maybe we need to take an even more comprehensive view of this?
That's an excellent question. So yes, one of the high profile, I talked about the high profile hits. I didn't talk about the high profile misses, right? One of the most important high profile misses was actually Madison, for example. Huge breach, and according to our models, they were an extremely low probability of breach. They were well below the 50% mark. And we don't quite understand why that is. I mean, if you look at the underlying data from the models, it also is extremely clean, yet they had a breach. And we can't really know for sure, but the hypothesis there is perhaps we are unable to detect the insider threat, where there is some activity on the inside that is not a true representation of cybersecurity policy, but it is purely human element, maliciously aimed.
So if you could just find a way of measuring human dishonesty ahead of time, you'd be set.
Thank you.
Hi, this is Yana Kinesrik from Comcast. Excellent talk. I have a question. Does it make sense to have among predictors, or maybe you already did and I just didn't catch it, also in some sense how, I don't know, how sensitive a target something is? Because I'm thinking that all else being equal, one type of companies may be more of a target as opposed, you know, like sort of size. I think maybe you did have size of company, but maybe some sort of measure of prominence, number of mentions, you know, in the press or something like that. Like some entities may be more prone to being attacked than others.
Absolutely. So you're right. The output of the model is only going to be as accurate or as useful as the input data that went into training it. So we're hoping that a lot of the factors that you're talking about, things like targetability or target preference, is also going to show up in the historical data that we're using to build our labels. So if certain sector is if a certain sector like the financial sector or the energy sector is more likely to be targeted, our expectation is that will show up in the historical reports, data breach reports as well. And that bias will then drive the trained models as well. Go ahead. Just follow up.
I was just asking, but you don't have it explicitly as a feature. You think that just that financial companies will be in some sense described by whatever features you're using rather than having a categorical, you know, feature financial versus
That's right.
retail, whatever.
So we did try to include sector level information. This is something we're working on right now. But as it turns out, mapping organizations to the sectors is in itself a challenging task. And in a lot of cases, it has to be done manually by scrubbing through the data. So
Yeah, I hear you.
if you know of a good data source, please, let's talk.
Hi, Jay Gillen, Finera. I was going to ask questions very similar to some of these about how you could be confident that you had enough data sources to cover the range of different risk factors and things like being on outdated software loads and stuff like that. We could probably do a poll of people in the room and come up with 100 other security risk factors that you won't be able to get data on.
Yep.
So I'm of the same mind that I think those commenters were, that this model is going to be very incomplete for a very long time, precisely because people don't know where the risks are and they don't reveal what their own internal risk profile is in a way that is obvious to the outside world. But I'm going to follow up with a different question, which is, has anybody from Wall Street asked you for your data set so they can short companies that have the highest risk scores?
Yes, let's talk about that offline. In terms of the expanding or improving the actual data that we're using to model, to build these data models, we're continuing to expand the range of activities that we collect. We've since included a much broader set of policy indicators. For example, simple things like whether you have a policy for managing development web servers. People, in a lot of organizations, people have development systems which are open to the public unless explicitly locked down. Some organizations are much more careful about it, and those are the sort of subtle hints that we're now expanding into detecting. So yes, we're expanding the scope of what we're collecting.